On number 5, it tells you the empirical formula is this. The molecular formula is what it's wanting. Hopefully you guys have this written down on your periodic table. You're dividing two masses together. Two masses of the same, of a compound. You're just dividing them. This one's pretty easy because they gave you the empirical formula. They don't always do that. So formula mass is the same thing. You can say formula or molecular mass. To find the empirical mass, I have to add this up. Then you just divide them. Okay, so what you do with that new number is multiply every single subscript. So it was when you calculate the molecular formula, it should get bigger because you're multiplying. So if you get a question like this, just plug stuff into the formula. You're going to be given one mass. That's always going to go on top. The other thing you have to figure out, empirical mass, goes in the bottom. To find the mass of this in grams, you have to look to the periodic table. This was carbon, and we had 2 of them, so I multiplied it by 2. Hydrogen, I had 5 of them. When I add them together, the empirical mass, the mass of that is 29.06. I got 3, and then I multiply it by the old subscripts. Any questions on that one? A compound has an empirical formula of this and the molar mass of that. What's the compound's molecular formula? Okay, so you put 180 on the top. This is the empirical formula, so in order to find the empirical mass, okay, this is the formula you guys are using. You have to add it all up to find the mass. Divide them. What do I do after I divide? Now I need to multiply. I multiply by the original. So the original was now it's going to be because I did C, this is pretty much 1 times 6, 2 times 6, 1 times 6. Any questions on how to find molecular? Molecular is the only one that you multiply and they get bigger. The formulas get bigger. Just remember this formula and you should be good. I'm going to go down to number 8. Which term is described as the lowest whole number ratio? Okay, so lowest whole number ratio means you cannot like reduce it. In all of the, this was molecular, and the one above it, right here, this is molecular. They're very large numbers, and those are not in the lowest form. They could be smaller, okay? So if it's not molecular, the other option's empirical, and that's the correct answer. An empirical formula is in the lowest whole number ratio. Generally, you can't reduce them. They're already in the smallest numbers possible. Which is the correct molecular formula? So it wants the molecular formula for the compound whose percent composition is shown. This should actually say empirical. Hopefully you guys got this correct on your last exam. Okay, so this is how you should have started. You turn all the percents to grams. So you need 3 T-charts, one for K, one for N, and one for O. Because you're going to convert all of these to moles, all the grams to moles. These match. How much does potassium weigh on the periodic table? Thank you. And nitrogen? Oxygen? Okay, so all you need to do is divide the two. 38.62 divided by 39. 13.87 divided by 14. 47.51 divided by 16. And then you're going to go with the smallest mole. The smallest number is 0.99. Divide them all by 0.99. Whatever you get from those answers are your new subscripts. So K, you got 1. N, you got 1. And O, 2.9, which is close enough to 3. So KNO3. Did you guys get that in your exam? Number 10. From 1942 to 1945, nickels were made of an alloy. That means like a mixture of metals. There's 35% silver, 9% manganese, and copper was the rest. I'm going to figure out how much copper there was. You get 100%. Everything has to add up to 100. So I'm going to do 35 plus 9 first. That gave me 44, so I'll do 100 minus 44. So there's 56% copper. If one of the nickels has a mass of 5 grams, so total mass was 5 grams. What's the mass of copper? What's 56% of 5 grams? That's what you do to find the answer. You could could think of it as part over whole. The part would be 0.56. No, you can't think of it like that. It's going to turn to a percent. So 56% of the price. So if you guys have something you want to buy that's on sale and it's 50% off, to find the price, you do 0.50 times however much that the thing that you want. If it's 25% off, 0.25 times the cost of the pair of shoes. What's the formula mass of ethyl alcohol? Oh, it just wants the weight. You guys should know how to do this. Oh wait, there's 6 though. You're adding these all together. I think 25. I added it all together and got 46.07. Number 12, the number of representative particles of a substance present in 1 mole is Avogadro's number. Representative particles, Avogadro's number. Any questions so far on anything? This one was a good question. You guys probably saw in your exam. It says, which substances have the same empirical formulas? So which ones will reduce to all look the same? So I'm going to start with 4. This could be actually, okay, because I just reduced by 2. 2 went into 2 once, 2 went into 4 twice. So that's the same, that's the same. Now I'm going to do number 3. Three can go all into them. Let's see. Or 6 can go in all of them. So 1, 2, 1, which is CH2O. So those 3 are the same. I can't do anything with that 3 on sample number 1. So 2, 3, and 4. On this back side, I'm going to let you practice the Lewis dot structure. Needed minus available equals shared. Okay, somewhere where you could probably write on the top, hydrogen only needs 2. That's the only exception. All other elements need 8. To be an octet. So let's work one that they already did for us. HBr. So it needs, okay, hydrogen needs 2. Br needs 8. Where it says electrons available, just put the valence. Okay, hydrogen's valence is 1. Br's over here, and the valence is 7.